Hey guys, it's me again. I'm just here with the third part of the sequences video. And what I'd like you to do, we're going to cover pages 8 through 10 in this video from your packet. So what I'd like you to do is if you can try out examples, well, why don't you try out all of pages 8 and 9 on your own? Just take 5 minutes. It shouldn't be too lengthy. And see how you do. And then you can hit play and see what you got right and see what you got wrong. Okay, so when we look at number 15, I want to point out, sometimes they ask for a recursive formula and sometimes they ask for an explicit. In number 15, they're asking for the recursive. Now remember, a recursive formula has 2 rules. You have to define G sub 1, or a lot of times we use A sub 1, but this question is using G sub 1. And then you have to give a rule for the nth term. Without even reading the question and looking at the sequence, choice 2 and choice 4 are not recursive formulas, okay? These are explicit formulas, so they're out. They can't be the answers. All right, so then let's look at the first one. Oh, let's see what's going on here. So to get from 18 to 9, and then to get from 9 to 4.5, I mean, we could see, I think it's pretty straightforward. All we're doing is we're taking these numbers and cutting them in half, right? Half of 18 is 9. Half of 9 is 4.5. If you're not sure, remember, we can always use the calculator. Take a term and divide it by the term in front of it. 4.5 divided by 9 is 1/2. 9 divided by the term in front of it is also 1/2. So what that means is if we worked forward, we're multiplying by 1/2 to get from one term to the next. So choice 1 would be our answer. Choice 2 means we're multiplying by 2. If we were multiplying by 2, the numbers would be doubling. They'd be getting bigger as we go. All right, number 16. Now, number 16 also asks for a recursive formula. Oops, that was the eraser. All right, so a recursive formula, you have to have 2 sentences like we do in choice 2 and 4, okay? If they just give one sentence, that can't be a recursive formula. So I'm going to just cross off choice 1 and choice 3. All right, so let's look at our sequence. So here, well, let's look at our 2 answer choices. We're either subtracting 10 to get from one term to the next, or we're multiplying by 3/4. Now, to get from 40 to 30, you could subtract 10. But to get from 30 down to 22.5, we are not subtracting 10. So choice 2 is not our answer. If you want to check to make sure why choice 4 would be the answer, if you do 40 times 3/4, it'll give you 30. If you do 30 times 3/4, it'll give you 22.5. So choice 4 is going to be our answer. Okay, number 17. After Roger's surgery, his doctor administered pain medication in the following amounts in milligrams over 4 days. Okay, how can this sequence be modeled recursively? So you could see right off the bat, the Regents asked for the recursive formula a lot. I mean, these, so far are just Regents questions. And you can see the first 3 we did are recursive. All right, so remember, recursive has to have 2 rules, 2 sentences. Not 2 rules, but 2 sentences to the formula, like choice 1 and 3. So choice 2 and 4, we can rule out. All right, now let's see what's going on here. And again, because it's multiple choice, look at the answer choices. Are we subtracting 320 to get from one term to the next? Or are we multiplying by 0.84 to get from one term to the next? All right, well, let's try it. So 2,000 minus 320 is 1,680. But 1,680 minus 320 is not 1,411.2. So choice 1 is out. So choice 3 has to be the answer, but let's just make sure. All right, if I do 2,000 times 0.84, it does give me this second term. If I do 1,680 times 0.84, it does give me this third term. So choice 3 is our formula. This is the rule that helps us get from one term to the next. Okay, so number 18, the population of Jamesburg for the years 2010 through 2013 respectively were reported as follows. When they say respectively, they mean this is 2010, 2011, 2012, and 2013. Now, they're asking for, again, a recursive formula. So if we're asking for a recursive, we know it has to have 2 sentences to the rule, like choice 2 or 4. So let's cross off choice 1 and 3. All right, now both of these say the first term is 250,000, which is true. This one's saying we're multiplying by 1.00375 to get from one term to the next. And this one says we're adding on 937 to get from one term to the next. So let's try it out and see what works. All right, so let's take this first term and multiply it by 1.00375. Does it get us to the second term? Yes, it does. All right, so let's take the second term and multiply it by 1.00375 and see if it gets us to the third term, which yes, it does. If you want to try it one more time, see if when you multiply the third term by this, it gets you to the last term. All right, choice 2 seems to be our answer because whenever we multiply the previous term by this number, it gets us to the next term. If we were to try out choice 4, if we just kept adding on 937, although it works to get from the first term to the second term, it does not work. If you add 937 to this, it doesn't get you to this number. And same thing, if you add 937 to the third term, it does not get you to the fourth term. So choice 4 is out also. Okay, so the next question looks like it has pretty much the same idea going on here. They give us the population for 5 years, and they want to know how can it be recursively modeled. So again, there's been a lot of questions on recursive sequences. All right, well, we know that a recursive sequence has to have 2 sentences to it, right? The first term and the nth term, kind of like we do in choice 2 and 4. So choice 1 is out and choice 3 is out. Okay, so let's look at the differences between these two choices. Choice 2 says the first term is 15,700, which that's true. And it says that to get from one term to the next, you multiply the previous term by 1.023. So try it. Take this and multiply it by 1.023 and see if this is what you get, which you do. Then you take this and multiply it by 1.023 and see if it gives you the third term. Okay, and keep doing that. And when you do, you'll see that this rule does work. What we're doing is we're multiplying by 1.023 to get from one term to the next. And if you did look at this fourth term here, you would see that although you can add 361 to get from the first term to the second, that's not what we're adding to get from the second to the third or from the third to the fourth. So choice 4 doesn't work for us. All right, now, I was curious to see what you guys were going to do with number 20. I guess I'm not going to see since we're doing this through a video. But number 20, all right, they give us a recursive sequence. So it's saying the first term is negative 12, and to find the nth term, you take the previous term and multiply it by negative 2. Now, my first thought would be, well, let's try to write this as using the explicit formula. Okay, so since this is geometric, right, we're multiplying by negative 2 to get from one term to the next, this is the format of the explicit formula. Okay, so a sub n, I'm just going to write this out, is equal to the first term, which they tell us is negative 12. So I'm going to replace a sub 1 with a negative 12. Oop, I kind of got cut off. There we go. Times r, which we know is negative 2, right? Isn't that what we're multiplying by to get from one term to the next? To the n minus 1 power. Okay, so now here's the problem. I don't see that answer there. So we're going to have to figure out which one of the answer choices here is equivalent to this explicit formula, okay? Because if you notice this says n minus 1, none of the answer choices say n minus 1. All right, so this I think is the easiest way to do it since, and you may want to write this in your notes. Okay, I shouldn't have said you may want to write this in your notes. Please put this in your notes, okay? This is important. Since this is not an answer choice, since we don't see this here, I feel like the easiest way really to do this question is to substitute in a value for n and determine which answer choice is equivalent when you substitute in the same value for n. Okay, so for example, let's just say we substituted in 2 for n. Okay, wherever we see an n, we're going to substitute in 2. So in your calculator, you can plug in negative 12 times negative 2 to the 2 minus 1 power. Okay, so you can see that when I replace the n with a 2, that's equivalent to 24. Now, what you're going to want to do is you're going to want to replace all the n's in each of the answer choices with a 2 and see which one also gives you 24. Now, just in case more than one of them works, you have to check all 4. Because if you get more than one answer choice to work, you have to substitute in a different number for n and see which one of the two choices you can eliminate. Okay, so as you can see, I took the first answer choice and I replaced the n also with a 2. And this did not match up with the 24, so choice 1 is out. Now I did the same thing with each one of the answer choices. I just replaced the n's with 2's, and I just typed exactly what you saw. And as you see, choice 3 is the only one that matches up with this. So choice 3 is going to be our answer. Now, if you had, I just want to point this out again. The reason why you want to try all 4 of them is because let's say 2 of the answer choices matched up with 24. Then instead of plugging in a 2 for n, try a different number, plug in a 5 for n, and replace those 2 answer choices that checked out with 5 for n, and see which one actually does work out. Okay, so this is the last page that we're going to take a look at today, and page 10. And what I'd like you to do is try this page on your own, and then you can hit play and see how many you got right. And I just want you to point out, if you get stuck on number 21, please look back at what we did at number 20. Okay, that'll help you out with that. Okay, so for number 21, they tell us that the first term, this is written in recursive form. They tell us the first term is 6, and to find any term, you take the previous term and multiply it by 3. Okay, so this is geometric because we're multiplying by 3 to get from one term to the next. Now, if I wanted to write that in the explicit form, okay, it would be a sub n is equal to the first term, which we could see right here, is 6, times r, which here this is saying multiply the previous term by 3, so this is telling us the r, what we're multiplying by to get from one term to the next, is 3. And within the formula, that's raised to the n minus 1 power. Now again, just like in number 20, none of these say n minus 1. So we want to see which of these is equivalent to this. All right, so just take any value for n, and I'm going to take 2 again. And so replace this n with a 2 and see what this is equal to. And then replace all of these n's with 2 and see which one is equivalent. Okay, so I took screenshots of what I got in the calculator. When I replaced 2 into our formula for n, I got 18. The only answer choice that matched up with that was choice 3. So there's our answer. Now, honestly, what you also could have done, I think a really easy way to do this, is when they said that a sub 1 equals 6, you could have just replaced each of these n's with a 1 and see which one equals 6. So, for example, if you replace this n with a 1, 6 times 3 to the first doesn't equal 6, so choice 1's out. If you replace this n with a 1, 1 plus 1 is 2. And 3 squared would be 9. And 6 times 9 would be 54, not 1. If you replace these n's with a 1, 2 times 3 to the first would be 6. So a sub 1 would be equal to 6. So choice 3 would be your answer. And you didn't have to do all of this. Okay, so number 22, the average depreciation rate. So depreciation rate means that it's going down by a rate of a new boat is approximately 8% per year. Okay, so if it's depreciation, it's 1 minus the rate. So 1 minus, well, the rate is 8%, so 0.08. So 1 minus 0.08 is equal to 0.92. What that means is we're going to be multiplying the price of the boat by 0.92 to figure out its value from year to year. All right, so if a new boat is purchased at a price of $75,000, which model is a recursive formula? Let me underline that. Let me highlight that too. That's important. Representing the value of the boat n years after it was purchased. Okay, so we're looking for a recursive formula, which we know has to have 2 sentences to the rule, kind of like number 2 and number 4. So I'm going to cross off choice 1 and choice 3. Now here, instead of saying a sub 1, it's actually saying a sub 0. When you see a sub 0, instead of it being the first term, it means the initial term. So the reason they're using initial term here is because initially, when the boat was purchased, it cost $75,000. Okay, so the initial term is 75,000. Now, if we're multiplying by 0.92 to get from one year to the next, we're going to have to use our recursive formula for a geometric sequence. Okay, so here's the format. So instead of a sub 1, we already talked about why we're using a sub 0. Now this says a sub n is equal to a sub n minus 1 times the common ratio. So if we look at choice 4, I see the a sub n minus 1, and we're multiplying that by the common ratio of 0.92. So choice 4 is our answer. Okay, number 23. At her job, Pat earns $25,000 the first year and receives a raise of $1,000 each year. Okay, so this is her first year's salary, and we're adding to that $1,000 per year. So this is going to be arithmetic. Okay, we're adding to get from one term to the next. Okay, and I also just wrote out here what we're adding to get from one term to the next. The common difference is equal to 1,000. So it says, just come back to this. The explicit formula for the nth term of the sequence is, okay, so we could see this follows the format of the explicit formula for an arithmetic sequence. Okay, so for arithmetic, here's a sub n. This would represent the first term, which she makes in her first year, and then we have the n minus 1, and the 1,000 would represent the common difference. So which rule best represents the equivalent recursive formula? Okay, now we know for a recursive formula, you have to have two sentences to your rule. So two sentences like we have in number 3, as well as like we have in number 4. That's what that comma is doing. The comma's separating the first sentence from the other. So choice 1 and choice 2 are out. Okay, so this is the format for our recursive formula. It says a sub 1 is the first term. So they both say that a sub 1 is 25,000. That's what she's making her first year. Now, if you look closely, the only difference between these is this says a sub n minus 1. This says a sub n plus 1. We know the previous term is represented by a sub n minus 1. So choice 3 is the answer. Just to mention this, a sub n plus 1, that means you're adding 1 to n. So you're moving forward a term. So that would be the next term after the nth term. All right, so this is not what we use. So choice 3 is the answer. Okay, and then finally the last question for today. Savannah just got contact lenses. Her doctor said she can wear them for 2 hours the first day and can then increase the length of time by 30 minutes each day. So if she's increasing the length of time by a constant of 30 minutes each day, that's telling us that this is arithmetic. All right, so here are two types of formulas for arithmetic sequences. Okay, so now if this pattern continues, which formula would not be appropriate to determine the length of time in either minutes or hours she could wear her contact lenses on the nth day? Okay, so we have to look at this in terms of minutes and hours, really. Now, if we look at choice 1 and choice 3, they're following the recursive formula. So I'm going to go through these one at a time. So choice 1 says a sub 1 is equal to 120. Now, she can wear them for 2 hours on the first day. So if we take that 2 hours and convert it to minutes, 2 times 60 would be 120. So this is good when it's in terms of minutes. Then, if we follow our formula, a sub n is equal to the previous term, which is what this says, plus d, which is an increase of 30 minutes each day. So this is perfect. This is the recursive formula when written in terms of minutes. So this one works, so it's not our answer. We want to know which would not be appropriate. Okay, so then choice 3. Choice 3, it looks like they're using the recursive formula that we have down here, but in terms of hours, right? Because a sub 1, the first day, she can wear them for 2 hours. Now, a sub n would be equal to the previous term plus, if she can increase the length by 30 minutes each day, wouldn't that just be a half an hour, right? So plus 1/2. So that works out. That looks good. So choice 3 is not going to be our answer. We're looking for which one does not work. All right, so now we're on to the explicit formulas. Now, it looks like here they're doing it in terms of minutes, and here they're doing it in terms of hours. So let's take a look and see. If we were to do the explicit formula, let's plug minutes into here. So we could say A sub n would be equal to. Now the first term in minutes would be, if we took 2 hours and converted it to minutes, 2 times 60 is 120. That would be 120 minutes, okay, just like we said over here. The first term is 120 minutes. Okay, and let's just follow the format of this. So plus n minus 1 times d. Well, the common difference in terms of minutes would be 30 minutes, okay, 30 minutes per day. Now, we can see here that this does not look like this. It doesn't follow that format. But remember, I said you can always distribute and combine your like terms. So let's see if when we do that, choice 2 matches up. All right, so I'm going to bring down the A sub n, and I'm going to bring down the 120 plus, and when I distribute, I get 30n minus 30. Okay, so I'm going to bring down my A sub n, and now I'm just going to combine my like terms. So to do it in the order they did here, it looks like they just wrote the number first. So if we combine 120 minus 30, that does give us the 90 that we see right here. And then if I bring down this plus 30, I'm sorry, this plus 30n, it does match up with choice 2. Okay, this right here says the same thing. So choice 2 is not our answer because we're looking for what doesn't work. So choice 4 is, I guess, the answer, but let's just make sure. Okay, so if I were to write the explicit formula, and this looks like it's going to be in terms of hours, I would have A sub n equals, all right, so the first term would be 2, right? 2 hours. And then plus n minus 1 times, well, d, the difference, if it's in terms of hours, 30 minutes is a half an hour. So I'm going to replace that d with a 1/2 or a 0.5. I'm going to do 0.5 because it looks like they're using decimals here. All right, so now this, again, does not say the same thing as this. So let's work with it a little and see what happens. All right, so we have A sub n equals, I'm going to bring the 2 down, and when I distribute the 0.5, that's going to give me plus 0.5n and then minus 0.5. Okay, so I just distributed the 0.5 to both of these terms. Now when I combine my like terms, 2.2 minus 0.5 is 1.5. And then I can bring down this 0.5n. And then this does not equal this. So choice 4 is the one that doesn't match up. Choice 4 is the answer.